Hi, 7th grade. Welcome back to Videoland. Today we're moving on. 4.3, solving inequalities with multiplication and division. There's some new rules that we're going to explore. Okay, these came right from the book. Let's see if I can back up just a little. Okay, so if the integer is positive, the direction of the inequality, whether it's less than or greater than, will stay the same. Okay? When the integer is negative, the direction of that inequality will reverse. Okay? So we're exploring through some examples. Let's say that we have 18. 18, positive 18 is greater than 12. If we make it a fraction, right, these are whole numbers, right? If we make them into a fraction, if we say half of 18 is larger than half of 12, that's true, right? Because 18 cut in half is 9, 12 cut in half is 6, okay? If we take the same examples, 18 and 12, and 18 halves and 12 halves, but instead we make them all negative, the sign cannot remain the same. Negative 18 is smaller than negative 12, okay? Negative 18 halves, or negative 9, compared to negative 6 is less. So when the numbers, whether they are whole or fractions, decimals, etc., are positive, nothing happens to the sign, right? No matter the math that we do. But if they are negative, in order for the statement to be true, we're going to have to reverse the signs, okay? So we're going to do some examples to help keep that clear for you in your minds. But I just want to make sure that you see, right, that it does in fact change. When they're negative, it's no longer the case, even with the same numbers, right? Because the opposite is true when we're talking about negatives. So now we're going to actually solve some problems, okay? So first let's start with a coefficient. Do you remember what a coefficient is? It's the number attached to a variable. Right? Like when we're talking about a term or one side of the equation. An example looks like 3x. The 3 is the coefficient. Okay? So here are the rules that we will need for solving. Okay? If the coefficient is positive, the sign stays the same. We'll solve it normal, just like we did the equations from last chapter. However, if the coefficient is negative, we will have to reverse the sign. We'll have to switch the inequality. Okay, so it's really, the only thing that matters is if the coefficient is negative. Okay, so let's do some. All right. The directions say solve and graph. Okay. Negative 4p is less than 36. Negative 4p. So in order to solve this, I would draw a line through my equal sign. And then I'm going to do the opposite of what I see. I see multiplication, so that means I'm going to divide by negative 4. My coefficient is negative. So when I divide by negative 4 over here, that means I'm going to have to change this sign. So the way that I was taught is if I saw a negative in my coefficient, to circle the sign so that I remember to change it. So I'm going to make sure that I do that in my notes. When I divide -4 by -4, I just get 1p. When I divide 36 by -4, I get -9. But because it was that negative, I have to flip the sign in order to make the statement true. Okay, so the answer is p is greater than -9. And when I graph that, I'm going to have -9, 0, +9, because I want it to be balanced. I have an open circle on -9. And if p is greater, then that means it points to anything positive. Okay, to the right. Let's take a look at this example. I'm going to label these A, B, C, and D. So for our second example, B, in this case, if I draw my line down the equal sign, my coefficient is 2/3. There's a negative in the problem, -2, but it's not the coefficient. It only matters if it's the coefficient. So in this case, to get the variable alone, I have 2/3 times n. And since I want the 2 and the 3 to cancel out, I'm going to multiply by the reciprocal. So I need 3 on the top so it can cancel out with 3 on the bottom. I need 2 on the bottom so that it will cancel out the 2 on the top, right? All these turned into 1s, and I'm left with just an n. Whatever I do to one side, I have to do to the other because that twin rule. So I'm going to be multiplying by 3/2. And maybe I'll just put a 1 so that it's easier to keep track of my numerators and denominators. 2 and 2 will cancel out into 1s, and I'm left with a -1 times 3. The coefficient was positive, so the sign is going to stay the same, and I end up with a -3 as my answer because I've got 1 and times 1 on the bottom. Okay. If I'm going to graph this, I want to keep it balanced, so I'm going to do -3, 0, and +3. I have an open circle on -3, and n is supposed to be greater, so like the last one, I'm going to point to the right. For funsies, I'm going to add an equal line. I didn't realize that none of these inequalities had or equal to in the problem. Okay, so I'm gonna add those to both C and D. Okay, so taking a look at example C, here I have draw a line through my equal sign / inequality. I have f divided by 5, f over 5. So since I want to get the variable alone, I need to do the inverse operation, the opposite of what I see. It's a +5, so I'm going to multiply by +5. What I do to one side, I'm going to do to the other. And I'm left with f, same sign, is less than 20, or equal to, because we added or equal to. So, to graph, I've got -20, +20. This time, because it's or equal to, I have a closed in circle on 20. And since f is less than or equal to, I need to point to the smaller numbers. Okay, so that means anything negative. And then the last one, D. -7y is less than or equal to 49. So I see that I have -7 times y. In order to get the y alone, I need to do the opposite. So I'm going to divide by -7. Because this coefficient is negative, I'm going to circle my sign so I remember that I need to flip it. I need to get the reverse because the coefficient is negative. -7 divided by -7 is just 1. So I'm left with a y on the left. I need to remember the twin rule, right? So divide by 7 is what I need to do on the right. Divide by -7. 49 divided by -7 is -7, right? Because a negative times negative will give me that positive. And because the coefficient was negative, I need to flip the sign. So instead of less than or equal to, it is now going to be greater than or equal to. And then I need to graph that. So on my number line, keeping it balanced, I have 0, -7, and +7. And I have a filled in or closed circle on -7 because it can be equal to. And y is greater than. It's greater. So any number bigger, +7 is the number I was thinking in my head. That's what we're going to point it to. Okay, so today everything is similar to when we had equal signs, right? When we were working on equations from chapter 3. The difference is only this piece right here, okay? When the coefficient is negative, you have to flip the sign. The steps are all the same to get the variable alone and to do inverse operations and then to do the twin rule and then graph. If you have any questions, come see me at office hours. For homework, we are going to be on page 168. And let's do numbers 6 through 20 evens. Like I said, come see me if you get stuck or you have any questions, okay, guys? Good luck.